Alright, this short video will cover the answers to question 4. 4.1, explain why propene is a gas at room temperature. If we draw out two propene molecules, you can clearly see that they're non-polar, and so you're going to get very weak van der Waals forces existing between those molecules. So the answer would be that weak van der Waals forces exist between propene molecules, and hence propene boils below room temperature. In fact, if you check the boiling point of propene, it turns out to be minus 47.6 degrees Celsius, so it boils well below room temperature. 4.2, propene reacts with water to form alcohol, a very common reaction. 4.2.1, state the name of this type of reaction. It's an addition reaction. In particular, it's hydration, so either addition or hydration. 4.2.2, two reaction conditions for the reaction. Firstly, we need excess water, and secondly we need a strong acid catalyst. Concentrated sulfuric acid would do. 4.2.3, the chemical equation using full displayed structural formula. We'll start with propene, 3 carbon atoms with a double bond, reacting with water. Don't forget to draw water out in its full displayed structural formula. The double bond will break in an addition reaction, and then we need to use Markovnikov's rule to decide where the H goes and where the OH goes. Remember, the hydrogen goes onto the carbon that already has more hydrogen, so that's the end carbon. So the hydrogen would go there. The OH would then go on carbon number 2. And finally, 4.2.4, the IUPAC name for the product. It's 3 carbon, so it's prop. It's an alcohol, so it's propanol, and the alcohol group's on carbon 2, so propan-2-ol would be the IUPAC name. 4.3, propene can also be formed from an alcohol. Remember, if you're forming a double bond, then that kind of reaction is going to be an elimination reaction, and so state the name of the reaction. It would be an elimination reaction. You'll be removing water from the alcohol, and so it's also called a dehydration reaction. Chemical equation, we draw out our propanol, showing all the bonds. That then reacts to form the double bond. There's our propene, and of course water would be removed. 4.4, propene is also used to manufacture a very important polymer. The name of the polymer. Polymers are named by using the prefix poly, and then after that prefix putting the name of the monomer. And so because we have a polymer formed from propene, we call it polypropene. An equation to illustrate this polymerization reaction, we say that we have n number of propene molecules. So there we've drawn a propene with n in front, n number of propene molecules. By addition polymerization, that then forms a long chain of those monomers bonded together. Because an addition reaction has taken place, the double bond breaks, and we indicate the repeating unit capturing it in brackets, and the little n outside indicates that it repeats n times. One use for the polymer can be used in plastics, packaging, textiles, or as rope. Alright, 4.5, 1,2 dichloroethane is heated under reflux, undergoes elimination. And we're told that one of the products is hydrochloric acid. Firstly, explain the phrase heated under reflux. That means that the reactants are heated in a flask, and that flask is fitted with a condenser. And as the reaction proceeds, the vapor products would rise up the condenser. They're cooled by the water within the condenser and then condense, and that condensate then drips back into the reaction vessel. So that's a description of heating under reflux. Chemical reaction using full displayed structural formulas. We start with 1,2 dichloroethane. Now we are told that one of the products is hydrochloric acid, HCl, so we know then that we must form chloroethene, and then there's our HCl, that's the other product. And besides heating under reflux, one other reaction condition, we need a concentrated solution of a strong base, sodium hydroxide or potassium hydroxide, dissolved in ethanol.